Warm greetings, my dear students. Today's topic is conic section. I'll give you the introduction first, okay? So, in the preceding chapter, we studied various forms of equation of a line, right? We know that if the slope and one point is given, how you can write the equation. And then slope and y-intercept, then 2-point formula, then actually x and y intercept. So you know all the various equations, right? So here it says the curves. So sorry, you have come across straight lines in the last chapter. Now we are going to see curves. Okay, I'll teach you about circles, ellipse, parabolas, and hyperbolas. Okay, so the names parabola and hyperbola are given by Apollonius. He is Apollonius. See his age. See when Apollonius to 262 BC to 190 BC. So, BCs are, from the negative infinity to zero. Zero is the maximum for BC, right? So it is decreasing now. 262 BC to 190 BC he lived, right? Then these curves are in fact known as conic sections, or more commonly conics, because they can be obtained as intersections of a plane. Okay, so the plane is intersecting. We are going to see that how the plane is intersecting. Okay, the curves where the planes are intersecting. So it has wide range of applications in planetary motions, right? And then in designs of telescopes, antennas, reflectors, in flashlights, automobile headlights, etc. So now in the subsequent sections, we will see how the intersection of a plane with a double napped right circular cone results in different types of curves. Okay. So we are going to see the sections of a curve right now. So it is the section of a curve. Okay. Let L be a fixed vertical line. This is fixed vertical line. And M be another line intersecting it at a fixed point. Okay. Where is the fixed point? This V is a fixed point. And inclined to it at an angle of alpha. Okay. M is another line. Okay. So suppose we rotate this particular line. It is about to rotate like this. Okay. It is about to rotate like this. Okay. Then around the line L in such a way that the angle alpha remains constant. Like that, the rotation will be. The alpha should be remain constant like. So wherever it is rotated, the alpha should be remains constant. Then the surface generated is a double napped right circular hollow cone, right? Do you imagine that? See, for example, how the curves are made, okay? How the conic sections are introduced by the famous mathematician. So Apollonius, right? He only derived how the curves are, okay? In this manner. See, for example, if the curve is rotating like this, this is the maximum, right? So from here to here, then it follows a right circular. We can say it is a double napped right circular hollow cone, right? Double napped. One cone is here, another cone is here. What is the meaning of right circular? The radius of the cone and the height of a cone are intersecting at right angle. So it is making a right angle. Okay. So this is how the cone is, we can able to refer hereafter how the cone is produced. Double napped right circular cone. Okay. So I think you can able to understand this concept. This is highlighted very neatly and clearly in your book, okay, textbook. Then we'll move on to this, okay. So this is how the generator is, okay. Only one line is fixed, okay, and then it has the fixed point V. This line is fixed line L and fixed point V, and another line M, which is rotating, okay, with respect to this fixed point, so that the angle also remain constant. This alpha is the angle making with the line, fixed line L. So that is also constant, right? Always it should be kept constant. Okay. Then it forms a double napped hollow circular cone. Okay. Right circular cone. Okay. So this is what upper nap and lower nap and everything. So this is a plane. Suppose if you introduce a plane here, plane means 2D. Okay, so the plane is cut this particular nap, upper nap, by this angle beta. Okay, then the point V is called the vertex. So it is the vertex of a cone. Okay, and the line L is the axis of the cone. The fixed line L is the axis of the cone. The rotating line M is the generator of the cone. Got it? So generator, fixed line is the axis. The fixed point is the vertex. The vertex separates the cone into two parts. Okay. If we take the intersection of a plane with the cone, the section so obtained is called a conic section. Can you able to understand this? Now you know how the cone is generated. I mean, next year in physics also you will see this concept, okay, in learning about electricity. Okay, how the potential is, I mean, we can able to understand the equipotential surface by means of this conic generator. Okay, so keep this into your mind. Okay, it is very, very important for your higher class. As I am a professor, physics professor, I will emphasize this to my children always, to my students always, like this. There are so many concepts or basics you must learn from class 11 and 12, so that it is easier for you to understand the complicated structures and complicated concepts in engineering degree. Okay, otherwise the engineering degree also be a complicate for you. Okay, keep this point especially into your mind, then you'll be remember me when you were in third year of your engineering degree. Okay, suppose if you are taking electrical, electronics, mechanical engineering, like this, you'll be having this kind of structures. Okay, you are going to learn in your third year. Okay, so this is very important. Keep this into your mind, how the conic sections are made. Okay, so you must remember this Apollonius guy. Okay, he was the very, 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 very important person for this. Okay, so with the two lines, one fixed line and one rotating line. Fixed line is known as the axis, rotating line is known as the generator. It generates a cone. Got it? So this is the basic. Then it is called a conic section. Okay, so the conic sections are the curves obtained by intersecting a right circular cone by a plane. Okay, so based on this angle beta, we are going to see this beta. Beta is the angle made by a plane. So conic sections depends on the position of the intersecting plane with respect to the cone and by the angle made by it with the vertical axis of the cone. Let beta be the angle made by the intersecting plane with the vertical axis of the cone. That you know? Okay. So how about this beta? That we are going to see. When the plane cuts the name, okay, see, of the cone, we have the following situation. If it cuts the plane, beta is equal to 90 degree exactly, that section is a circle. You know that, right? Suppose this is a conic section. If the plane cuts exactly perpendicular, then if it cuts, then the remaining part is like circular. Okay, so the section will be the circle. If alpha and beta and 90 degree we are talking about, if beta lies between alpha and 90 degree, okay, then that is the ellipse. We can see that cut right now. It is clearly given in your book. See here, this is circle, right? And this beta lies between alpha to 90 degree. Then what happens? It forms a oval shape or elliptical shape. Okay. What is the third condition? Beta is equal to alpha. Then that is a parabola. Okay. If beta lies between 0 to alpha, okay, it should not be negative. Definitely. It is minimum value of the beta angle is 0. So if it lies between 0 to alpha, okay, then that is hyperbola. See the parabola. What is the parabolic condition? Alpha and beta should be the same, alternate angle, right? So then it is parabola. If if the beta lies between 0 and alpha, like this, very small, 0 to alpha, then it is very straight to this particular fixed axis, right? The cut will be. Then it forms a hyperbola. I'll show you all the shapes right now. This is the shape, circle, and all the shape I will show you very clearly. Yeah. So this is the circle, and then ellipse, then hyperbola. See, hyperbola, then it is parabola. Okay. So you know how the section will be, right? If the plane is sectionize the upper nap of the core, which is generated by two lines, then you can able to understand that section is circle. Okay, if you talk about the four quadrants of the circle, you know everything is same. And then ellipse, how the angle will be, that also you know. Angle beta should lies in between 90 degree, alpha to 90 degree. Okay, so here it is exactly perpendicular. Beta is equal to 90 degree. And then what is the condition for parabola? The condition for parabola is alpha is equal to beta. Okay, the condition for the parabola is. So you'll be getting this section. Okay. What is the condition for hyperbola? The beta angle beta lies in between 0. 0 is the minimum and alpha. Then you'll be getting hyperbola. Okay. I hope it is clear for you. You are going to see all these things in details. Okay. So in your book, it is clearly given all the details and so many problems are explained in this particular chapter. So before that, I will give you key points based on this. So can you all copy down? Copy this. So I will say the key points. So the curves obtained by slicing the cone with a plane not passing through the vertex are called conic sections or simply conics. How we can define the conics? Okay, the curves obtained by, all of you copy this, slicing the cone with a plane not passing through the vertex. That is very important. So in your own words and for your own understanding, I'm giving this kind of points. Okay, passing through the vertex, not passing through the vertex, are called conic sections. Or simply we can say conics. Conics means conic sections. Okay. Then we can say circle, ellipse, parabola, hyperbola, or curves which are obtained by the intersection of a plane and cone in different position. That we know. A conic is the locus, right? It is the locus of a point which moves in a plane so that its distance from a fixed point bears a constant ratio to its distance from a fixed straight line. That you know, right? So the fixed point is called the focus. Okay? The fixed straight line is called the directrix. And the constant ratio is called the eccentricity. That is denoted by E. Okay? Eccentricity is E. Now you can able to understand how it comes, right? Okay. So this is all very important. And then circle, in circle, the set of all points in a plane that are equidistant from a fixed point in that plane. Right? Set of all points in a plane. Like we can explain, if this is a plane, the section will, I'm just exaggerating the section. This is a plane. In that, if you are locating any point, this point be P of x comma y. Okay? So this will be very important point. And then this is center, for example. And here the point is P. The center we can say H comma K. It is a letter given in your book. This is the point. Okay. It is actually CP is nothing but radius. This is the radius of the circle. So what is the distance formula you can able to use? You can write. If you square it, then it will be x minus h the whole square plus y minus k the whole square is equal to r square. This is the distance formula. You can use it. If the center coincides at an axis, I will draw like this. If the center is coinciding at the origin of two axes, x and y axis, this is a plane, right? So if the center is here at the origin, then h comma 0 is h comma k is 0 comma 0. Then the equation of a circle is, so last chapter you have learned equation of a straight lines. Here equation of the curves. So equation of circle is x square plus y square equal to r square. I hope you can able to understand this. This is all about the circle. Okay. You know this. Okay. So and then parabola and everything. I will teach you in other sections. So I'll catch you then. Thank you.